I'm going to tell you how a web service can tolerate some typos without degrading security. So let's see. In a traditional password-based authentication systems, you submit your username and password in a login form, which is then submitted to a web service. And the server applies a strong cryptographic hash function on the submitted password and checks the output against a stored hash digest, the hash digest that were generated in a similar way at the time of registration. If the check passes, the server will allow you to log in. If it doesn't, then you are login failure. Even if you make a slightest mistake in your password, such as you forgot to capitalize the first letter of your password, the output of the hash function will be different, and the login will fail. Now, this is annoying. Wouldn't it be good if the server allows some small typos that users frequently make while typing their passwords? So this intuition leads us to construct a new type of password checking, what we call typo-tolerant password checking. In this checking, the server not only accepts the password that you used at the time of registration, but also some passwords, some variants of that password. And we already see some typo-tolerant password checking in industry. For example, Facebook has been accepting some variants of your password since 2011. So you can log into your Facebook account with the password that you used at the time of registration, or the password where all the cases of your password is flipped, or the case of the first letter is flipped. But when you looked into academia, in spite of the fact that there are plethora of studies on usability of passwords, we see very minimal work on password typos. Like apart from the fact that password actually, So apart from the fact that password actually happens, we don't know much about the password typos. So we start our project with a few simple questions. How can we build a typo-tolerant password checking system? Is it actually help? If we allow some typos, will it help users, and how it will help? And is it secure to do so? So in our work, what we did, we first defined this notion of typo-tolerant password checking. Then we did some study with Dropbox and found out that a lot of users are really affected because of typos. Sometimes they cannot log in, sometimes their login is delayed. Then we analyze the security of these systems, and we show that we can build some typo-tolerant password checking systems that does not degrade your security. So let's begin. So the first question is, how can we build a typo-tolerant password checking system? We use a simple approach, which we call it a relaxed checker. So it's basically an extension over the exact hash-based checking systems. It works in the following way. It checks the submitted password first in the standard ways. And if the check fails, then it will try to correct on behalf of the user. So it will apply one or more correctors on the submitted password and check in the standard existing exact checking way. Now, the benefit of doing the typo tolerance in the following way is, first of all, it's easy to deploy. You don't need to make any changes in the existing password hash database. And also, the server can choose what kind of typos it wants to tolerate. That's good, but there is a catch. The hash function used here is slow. It is intentionally slow and computationally expensive. So even if we want, we cannot just check too many corrections. So we need to find out a small set of correctors that actually that can correct a large swath of typos. So to find this popular typos or frequent typos, we did some study with Amazon Mechanical Turk, where we asked the workers to transcribe real passwords. And we were able to collect this password transcription data of more than 100,000 passwords from 4,300 workers across the globe. By analyzing the typos that the workers made, we found out there are a few typos that are very popular, such as accidentally pressing caps lock key. The other popular typos could be like adding an extraneous character to the end of your password, or flipping the case of the first letter of the password. There are other broad classes of typos that we discuss in the paper, but for the purpose of this talk, I will focus on these top 3 typos. This comprises 20% of all typos that users make. Now, the next question is, like, what is the benefit of allowing these typos? Is it really help in the real world? So to find that, we instrumented Dropbox production login infrastructure, and we counted how many login fails because of these top 3 typos. I would like to emphasize that we did not admit any extra login based on this checking. So we did not turn on typo tolerance. We just recorded the events that, OK, is it a failed login because of typo or not? And also, Dropbox has hundreds of millions of users, and we instrumented all the logins. What we found really surprising is in 24 hours period during our study, 3% of all users could not log into Dropbox because they made one of these 3 typos in their password. The people who could log in, but they had to resubmit their password, 20% of them failed. 20% of them could have logged into Dropbox could have logged into Dropbox 1 minute earlier if Dropbox allowed these 3 typos. So in summary, like allowing typos by allowing typos, Dropbox will gain several person-month of login time every 24 hours. So this means like typos are a serious problem, and if we allow typo tolerance, that will enhance users' experience drastically. Now the remaining question is it secure? So let's see in the traditional way. There are 2 kinds of attack against any password-based authentication systems. The first one is server compromise, where the attacker breaks in the server and steals the password hash database. This is also known as smash and grab attack. Now, here I would like to remind you that in case of typo tolerance, like to make a system typo tolerant, we did not make any changes in the password hash database. So like the attacker will get the same good old password hashes, that he would have gotten if the server did not allow typos. So basically, the attacker cannot take advantage of typo tolerance in this process. The next threat is the remote guessing attack. So where the attacker uses the standard login API of the server and tries to impersonate the user by guessing his password. Now here, remember, the server checks these guesses, so it can lock out your account after too many wrong guesses. And this is basically the number of queries that the attacker gets to basically compromise an account. We call it query budget, or queue. For example, in Dropbox, if you type like 10 wrong passwords against an account, the account will be locked out. OK. Now, because the server is allowing typos, when your attacker submits a password, the server not only checks the password that you submitted, but also it will check some extra passwords. So it looks like the attacker is getting some free guesses for every query. So let's do some maths. With every query, the server will get 3 free guesses, assuming that the server is implementing top 3 typo characters. With Q free guesses, it will get 3 Q free password guesses. And if the server did not allow typos, then there is no free guesses. That means the attacker success will shoot up by 300% because of typo tolerance. No. The last implication is not correct. The reason is it's not the number of passwords that determine the attacker's success. It's the aggregate probability of those passwords. So had users chosen passwords were like uniformly distributed across all password strings, this will be the case. But users don't choose passwords uniformly. Like we know the password distributions are heavily skewed towards the head. So that means the attacker success will be 300%. But to find out what will be the exact advantage of the attacker, we did some simulation study using public password leaks. So we used PHP-BB and MySpace password leaks as a proxy for the real password distribution. And then we instantiated an adversary. The adversary we assume is optimal in the sense it knows the distribution of passwords, and also it knows anything other information it needs to check the password. For example, in case of typo-tolerant checking, it knows the characters. And the goal of the adversary is to impersonate a user into the service. So it might be able to, it might have to guess the exact password in case of exact checking, or some password that will enable checking enable login in case of typo-tolerant checking. So for exact checking, the best strategy of the attacker will be to pick the most probable Q passwords. In case of typo-tolerant checking, we used a greedy algorithm to compute Q passwords that will maximize its probability. So now let's see the result. So here in this graph, the height of the bar is the success probability of an attacker in being successfully impersonating an user in the server with a query budget of 10. The brown one is for the exact checking, and the blue one is for typo-tolerant checking. And you can see the difference in the attacker success is quite small. It's nowhere 300%. But we can do better with the following observation. The server is not obligated to correct every mistyped password. It can selectively deny correction or checking of a password if it finds it too popular or too risky. So what I mean, say the attacker submitted a password as password with all characters are uppercased. The server will check the submitted password and the 3 corrections. But among these 3 corrections, there is one password which is extremely popular. It's in top 10 of any password leaks if you see. And this is too risky to check, so server can decide not to check this, filter this password out, and check the rest. This intuition leads us to a nice theorem, what we call free correction theorem. This states for any password distribution, for any set of characters, and for any query budget Q, there exist typo-tolerant password checking systems that correct typos for no loss in security, 0 loss in security. Now, this is a theoretical result, and we prove it via construction. But I will not go into the details of the proof, and I will recommend you refer you to the paper for the proof. But I will say the main intuition behind it. The intuition is the server will always ensure that the total set of passwords that it will check, the aggregate probability is less than the qth most probable password of the password distribution. Now, there are 2 probability things. These 2 probabilities, how to find out these 2 probabilities? So we need a precise knowledge of the password distribution to find these probabilities. That's why it's a theoretical result, and it's hard to come by in practice. But we can always estimate these probabilities using public password leaks. So what we did, we used RawQ as a replacement for these probabilities. And then we computed the same attack simulation that we did previously. And the result is this. The result, you can see, with filtering based on this estimating password distribution using RawQ, the success probability of the attacker decreased significantly. Actually, now the difference in the success is 0.02%, which is essentially negligible. So this means we can create typo-tolerant checking that will enhance users' experience with essentially no degradation in security. So to recap, this is password typos in one slide. That we explored the notion of password, how to tolerate typos in login passwords. We did some study with Dropbox and ascertained that there are 3% of users who cannot log in because of some simple correctable typos. And correcting those typos does not degrade security. So the code for analysis and how to correct typos up in the GitHub, you can go and play with it. Now I'll open the floor for questions.
John Stallworth from UIC. It seems that this kind of technique would work much better with weak passwords. Is that true, and are you encouraging people with techniques like this to use weak passwords?
No, actually in the other way around. We are stopping weak passwords to be checked. We're encouraging people to use strong passwords because in the strong passwords, first of all, there is a higher probability of making mistakes if your password is not QWERTY or 1, 2, 3, 4, 5, 6. If you use strong passwords, then like if you have long passwords and you have a capitalized first letter, you forgot to capitalize the first letter, and you get a login failure. That's not.
Did you test out the effectiveness of the correction technique
Yes.
on strong versus weak passwords?
Yes, we did.
Oh, and
Yeah.
what was the result?
The result is so basically we instrumented the Dropbox. So there you see this 3% of increase, 3% of people could not log in because of this. If you correct these typos, they will be able to log in. So the way argument is the correcting typos will improve usability even if you stop the weak passwords, if you don't correct the weak passwords. You see what I mean?
For some definition of weak.
Weak is like
Weak
top
is
100, top
popular,
200 passwords.
not hard to crack,
Yes.
right? Those are two different issues.
What I mean by weak is like top 100 or 200 passwords in any leagues.
Yeah, but that's not a very large corpus. Anyway.
OK.
I had,
Go ahead. Oh, sorry. Did you look at all at sort of? It seems like one of the major threat models now for password guessing is cross-site sort of password password translation. And so I know that, and this is obviously anecdotal, but my parents, for example, the way they often choose passwords is they have like a couple base passwords and they'll do like slight permutations on them for different sites. And it seems like that's an area where, despite the fact that their passwords aren't common in the cross-site, like the cross-site password model, they may not have exactly the same password as on a different site, but it may be almost a typo of that password.
Yeah,
did you look at that issue at
No,
all?
we haven't actually. That's basically we call targeted attack. There had not been much study on targeted attack, and we are looking into it, like what will happen in targeted attack. I mean, we don't even know how targeted attack works in case of exact checking, let alone it for the typo tolerance checking. But yes, we did not check it yet.
Okay, thanks.
Abdul from Carleton University. Very nice work. It looks like it has sort of a motivation or a potential to motivate users to choose strong passwords, because as stronger the password they choose, the more help they get in fixing those passwords. So have you did any kind of studies aside of the user study you did to ask users whether they are willing to choose harder passwords if they get the chance of being allowed more errors or some sort of thing?
That's interesting. No, I don't know. I'm not aware of any of these studies, whether or not user will be willing to choose stronger password should there be typo tolerance. But there is like indirect conclusion, or some study has told that people choose weak password because typing password is difficult. So maybe there is a correlation, but yeah, that's a good idea.
So Thomas Gross, Newcastle University. I wondered, how did you actually instrument Dropbox and measure that typos were present?
So
did you learn to use the passwords in that process?
So we only when you find a submitted password is wrong, you correct the password and check again. The simple way, the relax checker, we simulated the effect of relax checker. Just we did not admit login based on that. We just logged in that this might be corrected.
So did you gain knowledge of actual users' passwords?
No, we did not.
Okay.
We don't see that.
You have time for one short question.
thank you, Peter.
Oh, sorry.
I have two comments, both real short. One is the errors are going to be culturally dependent by region. So different keyboards, different languages, different sets of characters. But the other thing is, if somebody has chosen a password which is one transformation away from a common password, then they shouldn't be using that password in the first place. So I'm not, you're kind of being circular here and preventing, you're just trying to identify a set of passwords that somebody was going to get anyway through search.
Yes. So that's a very good question, that there is a difference in typos based on input form factors. So we found out that mobile typos are different than if you type using keyboards. So there is a chance of typo correction based on the input devices. Thank you all.